Today we're going to look at inverse trigonometry. Our objective is to be able to find angle measures given two sides of a right triangle, an application word problem, one of the 6 trig ratios, and be able to find angle measures with and without a calculator. So how do you find an angle measure if you know two side lengths of a right triangle? First thing you're going to do is set up a trig equation and then use what we call inverse trig to solve for the angle theta. And the buttons for inverse trig are above the sine, cosine, and tangent, and they look like this. And we call it inverse sine, inverse cosine, and inverse tangent. And those are the buttons we're going to use. And to get there, just to show you, we're going to hit the second key, and then we'll hit the sine, cosine, or tangent button. So for example, if I hit second sine, that pops up. That's what we're going to be using today when dealing with our calculator. So I have two examples here, right triangles. I'm looking for theta, which happens to be one of the angle measures I have labeled, and we're going to actually set up a trig ratio, an equation like we did before. So if this is my theta, this is my opposite side, my adjacent side, and the hypotenuse. So I know the adjacent and the hypotenuse, which means I'm going to set up cosine. So I'm going to write cosine of my angle, and since I don't know it, I'm just going to write theta equals adjacent over hypotenuse. Now this is a function, it's cosine of theta. It's not cosine times theta, so we can't divide by cosine. It's kind of like when we had matrices and we couldn't divide by a matrix. We had to use inverse matrix. And it's going to be the same thing here. So it's cosine of theta. So to move the cosine over, in essence, to get theta by itself, what I'm going to do is the inverse of my cosine value. And that's at cosine -1 of 8/17. So I'm going to pull out the calculator. Now the thing I want to be careful with is, what do I want my angle to be in? Is it a degree or a radian? If it's not told to you, usually we typically deal with degrees. So I'm going to check my calculator. And it is in degree mode. If it was in radian, I'd have to switch it over. And now I can type in exactly what I see. Second cosine, and then 8 divided by 17. And it's as simple as that. And then I just write down my answer. I'm going to get my angle measure is equal to, or approximately, since I'm going to round, and I'm going to do 2 decimal places, 61.93, and always make sure you put a degree symbol. It's technically wrong if you don't, because remember, if it doesn't have the degree symbol, it's a radian, and this isn't 61.93 radians, it's 61.93 degrees. Okay, let's look at our second example. Here's my theta. I'm going to label the sides O, A, and H. Okay, I know I have the opposite side and the hypotenuse, so O and H is sine. So I'm going to take sine of my angle, which I don't know, equals the ratio of opposite over hypotenuse. Again, if I want to get my angle measure by itself, I have to do the inverse. The only time you ever use the inverse button is when you are solving for an angle measure, and that's how you remember. You hit sine, cosine, and tangent when you're solving for a side length, inverse sine, inverse cosine, inverse tangent when you're solving for an angle measure of 7/25. And I'm going to get an approximation for what my angle is. Second sine, 7 divided by 25. And again, I'm going to round that to 2 decimal places, so that's going to give me about 16.26 degrees. And that's all you have to do. So here we have an application problem, and it's always a little bit harder whenever you have a word problem because, one, none of the picture is drawn for you. So you have to draw the picture in order to get the equation right, and then you have to get the equation right in order to get the angle. So it makes it a little bit harder. So I want to read through it first. It says an Air Force pilot is flying at an altitude of 1,500 feet and must descend over a horizontal distance of 9,000 feet to land smoothly on an aircraft carrier. What is the plane's angle of descent? All right, so we know we have this plane somewhere in the air, and again, forgive my my picture, and it's flying at an altitude, which means how high it is above the ground, at 1,500 feet. Okay, and it says it must descend over a horizontal distance. So here's my horizontal distance of 9,000 feet to land smoothly on some aircraft carrier. Some aircraft carrier is somewhere, over here. So it needs to be 9,000 feet away. And again, it doesn't matter really where I draw this aircraft carrier. I mean, I can move it away, I can move it closer, but I know the distance it needs to land is 9,000 feet. So that's the part we have to worry about. So I know this is going to be a right angle because it's perpendicular when we talk about altitude. Now I want to know the angle's plane of descent. So I want to know at what angle it's descending down to this. So remember, that's like the same thing as angle of depression. So anytime you have an angle of elevation or depression, there has to be some horizontal line. So if the plane doesn't descend or ascend at all, it will be flying straight. But I want to find this angle right here. That's my theta. But if you notice, that's not even inside my triangle, and I need an angle inside the triangle. So there's a couple of things you do. The easiest thing and the most direct way to do it is to remember we have these parallel lines. The horizontal flight path and the ground would be parallel, which makes this angle and this angle here alternate interior angles, which means they are congruent. And remember, the angle of depression is equal to the angle of elevation, which means if you were up high and looked down at someone, the angle you had to turn to look down would be the same angle someone had to turn to look up at you. And that's kind of how I remember it. So now I can find this angle. So let's label my sides. If this is my angle, this is the opposite, this is the adjacent, and this is the hypotenuse. So what I know is the O and the A. O and A gives me tangent. So if I have tangent of my angle, it's equal to opposite over adjacent. Okay? And just like before, if I want to get my theta alone, I'm going to have to do the inverse tangent of 1500 over 9,000. Don't worry about reducing any of these numbers. If you have a calculator, might as well let it do all the work. So again, we're still in degree, so I don't have to worry about that. So turn the calculator on. I'm just going to do second tan of 1500 divided by 9,000. Close my parentheses. Hit enter, and it gives me a value. So what this tells me is my angle of descent is approximately 9.46 degrees. So again, what is the plane's angle of descent? Again, anytime it's a word problem, it's always best to put your answer in words. Angle of descent is approximately 9.46 degrees. And that would be your final answer. Okay, so let's look at our next example. A bird is sitting in a small bush 3 feet above the ground. The bird then flies to a nearby tree 27 feet above the ground. If the bush and the tree are 220 feet apart, what is the angle of elevation of the bird's flight? So now we have some little bush and we have some tree. Okay. Again, you don't have to draw pictures, but sometimes I like to do that. So we have a little birdie. Okay, a little birdie in the tree, or sorry, in the bush, and he's flying up into the tree. Okay, so he's going to end up here. So what do we know? We know right now that the bird is 3 feet above the ground. And we know at the end, the bird ends up being 27 feet above the ground. But if I look at this, if I draw on the ground, that's definitely not a triangle. It's a four-sided figure. It's actually a trapezoid because these sides are parallel. So how do I get a triangle in there? Well, what I'm going to do is, instead of drawing my line on the ground, I'm going to draw the line right here. Okay, horizontal from where the bird originally is. So what that means is that this length right here is no longer 27 because we're starting 3 feet above, which means this is now 24. So I know this angle is 24, here's my right angle, and I know that the tree and the bush were 220 apart. Well, if this is 220, we know that's 220. So here's my right triangle. Here's my right angle. This is now 24 feet. This is 220 feet. And since I want to know the bird's angle of elevation, is basically what it's looking for. So again, here's the bird. I have my horizontal line if the bird didn't go up or down, but I want to know its angle up. So here is the theta. So here's the theta in this problem. Again, opposite, adjacent, and hypotenuse. Opposite and adjacent is tangent. So I do tangent of my angle is equal to the opposite over the adjacent. My theta then is equal to the inverse tangent, again because we're solving for an angle, of 24 divided by 220. Just take your calculator, take inverse tangent of 24 divided by 220, and we get an angle of approximately 6.23 degrees. Again, make sure you remember the degree mark. So the bird's angle of elevation is approximately 6.23 degrees, and that would be your answer. So now let's kind of go a little bit more generic. Like, how do you find an angle measure if you know the trig ratio? So let's not worry about word problems or having an actual triangle. What if I just give you a value? So I'm going to give you an example. So what angle has a sine value of negative root 3 over 2? So this is going from our last lesson, 13.3, when we talked about the unit circle. And this should be really familiar as a unit circle value. So how would we actually figure this out? Well, what angle has a sine value of negative root 3 over 2? So what I should be thinking of when I know the sine value, if you remember from what we did in the last section, x comma y, x was our cosine value of theta, and y was our sine value of theta. So since they're asking for the sine value, I know this is the y value at some angle. So let's think about it. If we had our unit circle, where was y negative root 3 over 2? Well, y is negative down here, right, in quadrants 3 and 4. So negative root 3 over 2 and negative root 3 over 2 would have a 60-degree reference angle, because these points, negative 1/2, comma, negative root 3 over 2, and this point would be positive 1/2, comma, root 3 over 2. But what angles are those? Well, if we look at our reference angle, this angle is 240 degrees, and this angle is 300 degrees. So both 240 degrees and 300 degrees in a one rotation would have a sine value of negative root 3 over 2. But are those the only angles that have that value? And the answer to that is no. Any angle that's coterminal, or if you remember, coterminal means has the same terminal side, just different number of rotations. So basically, any angle at 300 plus 300 degrees so many times. So if I go a positive rotation of 360, that would also have a sine value of negative root 3 over 2. If I did 2 rotations, or if I did a negative rotation. Same thing here. If I did any sort of rotation, if I did that angle, or if I spun around a couple of times, any angle that stops right here is going to have a y value of negative root 3 over 2. So again, 240 plus any number of rotations, I'll just call it n rotations of 360 degrees, would give me a sine value of negative root 3 over 2. So how do we know which answer to use? If I'm just asking in general, this would be your answer. I would answer 240 plus 360n, where n is the number of rotations, or 300 plus 360n. Now if I asked in terms of radians, you would have to do a radian answer. 240 degrees is the same thing as 4 pi over 3. These are equivalent. Well, what's a rotation in radian? 2 pi. So if you wanted to write the general answer, it would be 4 pi over 3 plus 2 pi n. Again, 2 pi n just says we're going to do so many rotations to end up at the same answer. If we go to 300, that's 5 pi over 3. But if I wanted to rotate a bunch of times, that's 2 pi so many times. And the reason why we write plus is because n could be positive or negative, which would give me either a positive or a negative rotation. Those would be the general answers that you would give. If they restricted where you would look for your angle, then this would cut down significantly the number of answers you would get. And we're going to look at that next. How exactly do you know which answer to give? If I just say in general, you would do what we did in the last problem, where you put this number of rotations, this 2 pi n or 360n added onto your angle. But typically, we don't want every single answer. And what we have to do is restrict the domain of each inverse first. So that's how we know what answer we typically give. Because if you notice in our last problems when I used the calculator when I did inverse spit out one answer. They didn't give you a ton of different angle answers. They gave me one answer. And how does the calculator do that when we just looked and saw, for one example, I can come up with an infinite number of solutions. So what they did is they restricted the domain. Anytime we're looking for inverse cosine, which is cosine negative 1, or sometimes you actually see it written like this, arc cosine is how we say that. These are the same thing. Both of these mean inverse cosine. They say it's defined by 0 to 180. If you want to take the inverse of a value, so you want to take inverse cosine, your answer will be somewhere between 0 and 180 degrees. Okay, so you're going to go between 0 and 180 degrees, or between 0 pi and pi. That's where your answer is going to fall between. And I've just pointed out the unit circle values that fall in that range. But in a calculator, it could give me any answer. If I hit inverse cosine, it's going to give me any answer from 0 to 180 degrees. Now, sine and tangent are defined a little bit differently. Sine and tangent inverse go from negative 90 degrees all the way to positive 90 degrees. So if I type inverse tangent or inverse sine in my calculator, it's only going to spit out an angle measure between positive 90 and negative 90 degrees. Or, if I'm talking about radians, negative pi over 2 to positive pi over 2. And that's the only radian answers it would give me. And this is typically how we want our answers, unless it's told to us differently, unless they say, you know what, just give me an angle measure between 90 and 270. Then we would be forced to give an answer that falls into that range. But if you're using the calculator or using the definition, any inverse cosine, the answer has to be between 0 and 180. Any inverse sine or inverse tangent falls between positive and negative 90 degrees, or, like I said, the radian equivalent. So, how are we going to evaluate without a calculator? And the only way we could do that is if it's a unit circle value, because those are the ones we can find using our special right triangles. So there's a 4-step process that I find is easiest to answer this. First thing we're going to decide is what value do we know? Did they give me the x value, the y value, the y over x value, which is tangent, or the reciprocals? The second thing we're going to decide is what quadrant is our angle in. Is it in 1, 2, or 4? Because those are the only quadrants that are defined by our inverse cosine or inverse sine and tangent. Third thing I'm going to decide is which family am I going to look at? Is it the 30 degree, the 45, the 60, or the 90 degree family? And then the fourth thing is I'm going to find the angle measure that I'm looking for in either degrees and or radians, depending on what the question asks for. So I have 6 examples, and we're going to do these by hand. You will have to do this without a calculator. On any quiz or test, it will be a completely non-calculator section. So I'm expecting you to know and be able to recall from the unit circle where all these values lie. So in the first example, it says inverse sine of root 2 over 2. What this means in words, whenever you see this inverse, is it's asking what angle has a sine value of root 2 over 2. So the first thing we want to think about is what value is sine? Is sine an x, a y over x, or any of those reciprocals? Well, if you remember, sine is y. So what this is telling me is I'm asking what angle has a y value of root 2 over 2. So that's step 1. The second step is to figure out what quadrant we're in. So if you remember, sine is defined from positive 90 to negative 90. So sine has to be somewhere in this range. I know sine is the y value. Y is positive in this quadrant, negative in this quadrant. But if I look at my value, this is a positive value. So right now, I know my answer is going to be in quadrant 1. Okay, so now that narrows it down. Now I know my answer is between, say, anywhere from 0 to 90. My third thing is I want to think about what family has a y value of root 2 over 2. Does the 30 degrees, the 45s, the 60s, or the 90s have a y value of root 2 over 2? Well, for me, I can remember that root 2 over 2 happens at the 45 degree angle mark. So I know that this is my 45 degree family. So my last step is to answer the question. And for me, I want all answers in both radians and degrees, just for our practice. So what angle is in the first quadrant that has a 45 degree reference angle? Well, that is 45 degrees. What radian measure is at 45 degrees? That's pi over 4. So when I ask this original question, what angle has a y value or a sine value of root 2 over 2? That's 45 degrees and pi over 4. If we look at our second example, I'm asking for arc cosine, which means inverse cosine of negative 1. So this question is asking is what angle has a cosine value of negative 1? Well, the first thing I want to think about is what is cosine? Cosine is my x value. So I know I'm looking for x. The next thing I'm going to think about is where is my cosine, my inverse cosine defined? Well, it's defined anywhere from 0 to 180 degrees. So I know my answer has to be somewhere in here. And I know that cosine is positive in the first quadrant because it's x, and negative in the second quadrant. So since my value is negative, I know my answer is somewhere in the second quadrant between 90 and 180. So now I want to think, what family has an x of a negative 1? And I know that actually is my 90-degree family, my quadrants. Only at the 90s, 90, 180, 270, and 360, do I have an x or a y value of exactly 1 for the x's. So I know this ordered pair here, negative 1, 0, is where I'm looking. So in degrees, that's 180 degrees. In radians, that's pi. So the answer to the question, what angle has a cosine value of negative 1? It's 180 degrees or pi. The last example on this page for number 3 is tangent of theta equals negative root 3. So now this is a little bit different. This is what it looked like when we set up the problems in our first few examples. But remember, I want to know what theta is. So theta is equal to the inverse tangent of negative root 3. And you might think, well, doesn't this mean I'm using my calculator? And the answer is no, it's just a different way. I'm showing you 3 different ways you could be asked the same question. So again, this is asking what angle has a tangent value of negative root 3. So I'm going to think about this, and tangent is y over x. So this represents y over x, which for me, that means negative root 3 over 1, because I'm going to write it as a fraction. So I want to know when the y is a negative root 3 and the x is a 1. Well, we just talked about when x is 1 is at the 90s, but I definitely know the y is in a negative root 3 at that. So this must have been simplified at some point. So since it's not one of my 90 families, it must be a 30, 45, or 60. And if I think about all those ordered pairs, every one has a denominator of 2. And if you remember back from when we simplified fractions and our rational or complex fractions, if I have a fraction over a fraction, if the denominators are the same, they will end up reducing when I multiply by the reciprocal. So what this really means is that I had a negative root 3 over 2 for my y and a 1/2 for the x. So what I'm really thinking about is, where do I have an angle that has an x of 1/2 and a y of negative root 3 over 2? So that's going to be really helpful for the tangent. But I remember tangent is defined just like inverse sine is. So my answer has to be somewhere between positive 90 and negative 90. Since tangent is y over x, and I know both x and y are positive in quadrant 1, and x is positive and y is negative in quadrant 4, or my negative quadrant 1, I know my answer is going to be in my negative quadrant 1 because this is a negative answer. So I got to think about where my answer is going to be from 0 to negative 90. So what family is a 1/2 and a negative root 3 over 2? Well, that's my 60-degree reference family. So I know that this is going to be 60 degrees because this is my 60-degree family, the 1/2 and the root 3 over 2, and it's a negative root 3 over 2 because it's in my negative quadrant 1 family. So my answers have to go from positive 90 to negative 90. So my degree is actually a negative 60 degrees, because if my reference angle is 60 and I'm going down, this is going to be a negative 60. Well, 60 is pi over 3. So negative 60 is negative pi over 3. So again, to answer this question, what angle has a tangent of negative root 3? The answer is negative 60 degrees or negative pi over 3. Now my last 3 examples deal with cosecant, secant, and cotangent inverses. So remember, these are the reciprocals of sine, cosine, and tangent. So what I like to do first is I don't like to think about them in these terms. I like to switch them to the reciprocals. The reciprocal of cosecant is sine. So what this is really asking is, if this is negative 1 over 1, I'm going to take the reciprocal function, which means I'm going to take the reciprocal of this. The reciprocal of negative 1 over 1 is 1 over negative 1. So what I'm really asking is, the sine of theta equals 1 over negative 1 is negative 1. And just because the reciprocal of negative 1 ends up being negative 1, we don't have too much work to do. So again, this is asking, what angle has a sine value of negative 1? Remember, sine is my y. So you can really do all these problems as sine, cosine, and tangent problems. You just have to do a couple steps first. So again, sine is in one of these two quadrants, from positive 90 to negative 90. Where is y negative? In this quadrant right here, which is my negative quadrant 1. Because remember, it's the same values as quadrant 1, just only negative. Alright, so when is the y value negative 1? Well, that happens to be right down here at the 90 degree family. So I know this point right here is 0, negative 1. So my answer is, what angle has a sine value of negative 1 or a cosecant value of negative 1? The answer is negative 90 degrees, which is negative pi over 2. Okay. If I go to the next example, secant inverse of negative 2. Well, remember, the inverse of secant is cosine. So what I'm really asking for is, what's the inverse cosine? And if I take the reciprocal of this, it's negative 1/2. And make sure you don't do the opposite reciprocal. We're not doing perpendicular slopes. It's just reciprocal. So you just take the fraction and flip it. So remember, cosine is x, and cosine goes from 0 to 180. So what I'm asking is, when is the x value a negative 1/2? Well, that's going to be in the second quadrant. So now I want to think, what family has an x of negative 1/2? And that's my 60 degree reference family. So I know that I have a 60 degree, move that back a little bit, I have a 60 degree reference angle here. So if I have a 60 degree reference angle, what angle does that put that at between 90 and 180? Well, that puts me at 120 degrees. So if I have it at 120 degrees, that's the same thing as 2 pi over 3 in radians. So again, to answer the question, what angle has a cosine value of negative 1/2 or a secant value of negative 2? The answer is 120 degrees, or 2 pi over 3. In our last example, arc cotangent of root 3 over 3, well, that's the same thing as arc tangent. And if I flip the fraction, I get 3 over root 3. But that doesn't look right. So what I'm going to do is multiply top and bottom by radical 3, and that gives me 3 root 3 over 3. Well, 3 root 3 over 3 reduces to just root 3. So again, tangent is y over x. So if I look at this, this is what we had before. This really means, when is the y root 3 over 2, and when is the x 1/2? Well, tangent, again, is defined just like sine is, inverse sine, from 90 to negative 90. Tangent is positive in the first quadrant. So where between 0 and 90 is the y root 3 over 2 and the x 1/2? Well, that is our 60 degree family. So what angle has a reference angle of 60 degrees in quadrant 1? Well, that's actually 60 degrees, or pi over 3. So again, to answer this, what angle has a tangent value of root 3 or a cotangent value of root 3 over 3? The answer is 60 degrees, or pi over 3. I hope you feel a little bit better about being able to find angle measures given two sides of a right triangle, an application word problem, one of the 6 trig ratios, and to be able to find an angle measure with and without a calculator.